Hello Gems! Welcome back to the Super 30 series. For those who don't know, Super 30 series is a special grind for BITSAT 2024 wherein we discuss with every session we are discussing about 30 most probable questions for BITSAT 2024. We have already covered up about 4 sessions previously, so if you are interested in that, do check out. The links will be available in the description box of this video. Today we are doing session 5, so 30 more questions, and by the end of this series, by the end of March I believe, you will have about 300 most probable questions for BITSAT 2024. Okay, so if you are interested in that, do consider subscribing and join this series for free. So with that being said, let's begin with this video. Let's start things off with question 1 over here. In question 1, we are told that object moves with speed v1, v2 and v3 along a line segment, and the speeds are v1, v2 and v3 respectively in AB, BC and CD. It is given that AB is equal to BC is equal to CD, so this is along a line, and you are supposed to tell the average speed. Okay, so the situation is like this: we have AB, BC and CD, okay, equal distances and along a line, and the speed over here is v1, here it is v2, here it is v3. Okay, now we are supposed to tell average speed, which means it is total distance by time taken, right? Total time taken, that is how average speed is defined, so total t. Okay, now we can assume this total distance as x, and this will be x by 3, x by 3, x by 3, or wisely I can assume it 3x, and this will be x, x, x. Okay, you can also assume it as x, and this will be x by 3, x by 3, x by 3. Okay, I'm just making calculation simple. So total distance, we know the total distance traveled is 3x. Okay, don't worry about this x, it will be cancelled as you will see here. Now the total time, we can't write it simply, right, because there is no mention of time over here. We have assumed the distance, we know the speed in each of these sections, so we can find time. Time is distance upon speed, right? Speed is distance upon time, time is distance upon speed. So here we can write it as t1. So here suppose the time is t1, t2 and t3. Okay, each of this section. Okay, so total time will be t1 plus t2 plus t3, right? So here it will be 3x divided by t1 is distance of this section, which is x, and divided by speed, right? Speed in the section 1, which is v1. So similarly x by v2, right? Speed over here is v2 and here it is x by v3. Okay, so you can see x will cancel out, right? And you can take the LCM. So you'll get this v1 into v2 into v3, that will come in the denominator, right? So you can take it in the numerator, and what will you have over here? So v1, the rest of the 2, I'm just taking the LCM, and v2, for v2 you'll have v1 and v3, and for v3 you'll have v1 and v2. Okay, so if you see which option is matching, 3 times v1, v2, v3, and yeah, this pairs. Okay, so option B is matching. So if you see option D is dimensionally incorrect, option C will be the case if this was done in equal times. Okay, here the distances are equal. If the time was equal, the average would have been something like this, right? Distance upon time taken. So you could manipulate or you can guess which option was not correct. Okay, so you could eliminate some options from here, but if you solve it the right way, you will get option B as your answer. Over to the next question. Let's come to question 2 and 3 now. In question 2, we have an LC circuit. So the values of inductance and capacitance in this circuit will become twice and 8 times respectively. So L becomes 2 times L, C becomes 8 times C. Okay, you are supposed to tell what will happen to the resonant frequency. Okay, by what multiple it will change. Okay, it becomes X times. So what is X? Okay, so it's very simple because you know that omega for LC oscillations is this, right? Omega square is 1 by LC, so omega is this. So you are told that L becomes 2 times of L, so L prime I can call, and C prime becomes 8 times of C, right? So omega will be simply just use these values. Okay, it's 1 by under root, L is 2 times of L, so L prime C prime. Okay, I'm writing omega prime, so it is L prime C prime under root L prime C prime. So L prime is 2 times L and C is 8 times that. Okay, so 8 2s are 16, so 1 upon under root 16 LC. Okay, or it will be under root 16, root of 16 is 4, so 4 under root LC. This is nothing but omega, right? So if you see the new omega, which is omega dash, is omega by 4, right? So you have to multiply it by 4. Original frequency, multiply it by 1 by 4, you'll get the new frequency. Okay, so let's come to this one now. Here we have a body which is moving unidirectionally with so unidirectionally basically tells you that it won't change its acceleration, right? So the direction of force will remain the same. Okay, under the influence of a constant power, the square of its displacement is proportional to. So some of you might directly know the answer, and it's valid for constant acceleration, right? So here it is the case. So here the answer is t to the power 3. Okay, let's see how this comes. Some of you might directly know that s square is proportional to t cube, okay, for constant acceleration. That is true. Let's come to the solution. So we are given constant power. Okay, we'll start from there. Okay, we can treat power as a constant. Okay, so power is E by T, right? So PT is E. So from here, I wrote this relation because there is a T term, power is constant, so I can find a proportionality to T. That is what we want, right? So now energy, I have to express it in terms of displacement. Okay, I could have used the work format, or I can also use kinetic energy. I can write this as half mv square energy, right? And this will be 2 pt by m under root will give us v. Okay, because from v we can find s, right, displacement. Okay, so here I can write this v as ds by dt, right? So this is under root 2 p m. I'll write it like this because this is the term that is going to get integrated. So when I integrate, this will become s, dt goes to the other side. This is a constant 2p by m, right? So because power is constant, mass is constant, and here the integration of t raised to half. T raised to half will give us n plus 1, which is 3 by 2 divided by 3 by 2, right? So it will become 2 3 by 2. So this integration gives us this thing. Okay, so s is proportional to t, so I can write s is proportional, all of this is a constant, s is proportional to t to the power 3 by 2. But you are asked the proportionality of square of displacement. Keep that in mind. So square on both sides, so you'll get this is proportional to t cube, right? If you square, it's just multiplied by 2, right? So 3 by 2 multiplied by 2, 2 cancel, it's power 3. Okay, so s square is proportional to power 3 for a constant power source. Okay, so that is about this question. Over to the next one. Question 4 and 5 over here. In question 4, we have a resistance of a wire. It is given as 5 ohms. You are supposed to tell the new resistance of this wire if it's stretched by 5 times. Okay, so L, so the new length of the wire will be 5 times L. Okay, so this is not the only change. Keep that in mind because the volume of the wire is going to remain constant. Okay, V is equal to A into L. There will be no change in the volume. So when you stretch the wire, the area will also decrease. Okay, the length will increase, but the area will decrease. You can imagine, you can look at the cross section. First, it will be thick. Okay, so when you stretch the wire, the cross section will become thin, right? So area is decreasing, length is increasing, volume is remaining constant. Okay, so you have to also take into consideration this area, or you can see it from here that A into L is constant. So if L becomes 5 times of L, A should become, new area should be A by 5. Okay, or you can also use A1, L1 is equal to A2, L2. From here you can find A2. Here it is AL and this is 5 times of L. So this will be 5 by, right? So it will become 5 over here. Okay, and L and L will get cancelled. Okay, or basically area, so length is increased by 5 times, area will decrease by 5 times. AL is constant, that is what I am saying. Okay, so now the new resistance R dash will be rho L dash by A dash, right? Original resistance was rho L by A, original length, original area. Okay, so here it is rho will not change, it's the property of a material. L dash 5 times of L, area is A by 5. Okay, and this value was given as 5 ohms, right? So this value is 25 times rho L by A. Now you might be in a hurry and take the option as option D, which is incorrect over here because they have asked you for the value of new resistance. This is 5 ohms, so the old resistance over here is 5 ohms, so 25 into 5 is 125. Okay, so keep your eyes open. The correct choice over here is option C. Okay, the new resistance is 25 times the old resistance. So which value is 125. Okay. So let's come to this one. Here you are supposed to tell the ratio of speed of sound. Okay, ratio of speed of sound, not sound, speed of sound in hydrogen to speed of sound in oxygen. Okay, it's very simple because you know the speed of sound is given as gamma RT by m, right? And here R is constant, T is constant, same temperature. Gamma is diatomic, both of them are diatomic, H2O2, right? So the degrees of freedom will be same for them, and hence gamma is same for them. Okay, gamma is same for two diatomic gases, right? So the only thing that is variable over here is this m. Okay, so V depends on m as root of m. Okay, and it is inverse relation. So we are supposed to find the velocity of sound in, what is this? Velocity of sound in hydrogen, which is V of H2 divided by V of O2. So that will be m of O2, so inverse relation, right? And m of H2. So you're proportional to the square root, or inversely proportional to the square root. Okay, so here mass of oxygen, it is 32, right? O2, right? One oxygen is 16, two is 32. Okay, and hydrogen it is 2, I guess. Okay, because one hydrogen is 1. Yes. Now I am so confused with that. So this is root of 16. So root of 16 is 4, right? So the ratio is 4:1, option A. Okay. So that was about this question. Let's move to the next one. 6 and 7. Question 6 is from units and dimensions, and one question is always asked from this chapter. At least one will be asked from this chapter in whatever BITSAT paper that you see, and it will be also asked this year. So do it well. Okay. Excuse me. So here the question usually is based on dimensional analysis. So focus on that part. Okay. Sometimes error and mostly dimensional analysis. Okay. So let's come to this one. Here we are given that the frequency may depend on your density. So the relation is also given: radius, density, and surface tension. Okay, you are supposed to find the values of A, B, and C. So straightforward question, right? Frequency, you just have to apply, use dimensional formula on both sides, right? So here frequency has dimensions of per time, right? And there will be some dimensionless constant, so that we can neglect. Here radius is length, is to A. Density, mass per volume, okay, mass per, so kg per meter cube you can say, so L to the power -3. And surface tension is force per unit length, right? So force is mLT raised to -2, right? And here you will have L and L will get cancelled. So we have mt raised to -2 and that raised to c. Okay, so let's bring the like terms together. So m is to the power b and c, right? So m to the power b plus c here. Length is here a minus 3b, and there is no length over here. Let's come to time. Time is only there in this term, minus 2c. Okay, so let's compare the coefficients on both the sides. So here it is basically m0, L0, t raised to -1. Okay, so we can compare t first. So we'll get -1 is equal to -2c, meaning c is half. C is half. Okay, c is half, c is half. This option is incorrect. Okay, and okay. So c is half. We can also find b now. So we know that b plus c is 0. B plus c is 0. So b is minus of c. So b is minus half. B is minus half. B is minus half. B is minus half. Okay, this is anyways incorrect. This is also incorrect. Okay, b is minus half. Okay, so either one of these two. This is -3, right? Okay. So now we can find a. A is -3. A minus 3b is 0. Right? A minus 3b is 0. So a is equal to 3 times of b. B is minus half. So this is -3 by 2. So -3 by 2, which is option A. Right? -3 by 2. B is minus half. It is b. B is minus half and c is half. Okay. So that is how you find this. Pretty straightforward. You also do it for boards. Okay. So the question was pretty simple. Let's come to this one. The work done in placing a charge, this amount, on a condenser. Condenser is basically a capacitor. You can make it out. They have also provided you with capacity. Okay, so they might also use words like conductor. Conductor can be also a capacitor because it basically stores charge, right? And they might use condenser or capacitor. All these three words mean the same for you. Okay, so let's calculate this. Basically, the work done will be stored as potential energy, and the potential energy of a capacitor, in if you want it in terms of charge and capacity, okay, it is q square by 2c. Okay, you can remember any one of the form, half cv square, and then you can use c is equal to q by v, this relation, and manipulate to the form you want. Okay, for the charge it is this q square by 2c. Q square is this charge square, so square it. 8 square is 64 and 10 to the power minus 16, right? And here you will have 2 times of c. C is 100 microfarad, so 100 into 10 to the power minus 6. So okay, something off over here. This is 32 and let me check that. Oh, this was 18. Okay, so this was 18, so this will be 36, right? 18 you multiply it by 2, so that is 36. So this 6 you can subtract, so that will be 30 and this 10 again minus 2, 32, right? So 32 to the power 10 to the power minus 32. Okay, so which is option C. Okay, pretty straightforward. Work done is potential energy stored, right? So q square by 2c. So that's about these two questions. Over to the next one. Going to question 8 and 9 over here. In question 8, we are told that the kinetic energies of two bodies are in the ratio 16:9. You are supposed to tell if they have the same linear momentum, the ratio of their masses. Okay, it's very simple. I can see kinetic energy and linear momentum. What is the relation between them? K is equal to p square by 2m. Okay, same linear momentum, right? So p is constant, k is inversely proportional to m. Right, p is constant, k is inversely proportional to m, or you can use the other relation also. 2m k is p and equate 2m k1 is equal to 2m k2. Okay, so same result you will get. So k1 by k2, the ratio will be equal to m2 by m1, right? Because inverse relation, m1 m2. Okay, so now we know that k1 by k2 is 16:9. Okay, 16 by 9 is m2 by m1. We are supposed to find m1 by m2, right? We are supposed to find it in the same order. Okay, so first object first and second order, second object second. Okay, when not mentioned. So here the answer will be 9:16. Okay, basically you can see it from here also. If the kinetic energies are in the ratio 16:9, the masses will be in the ratio 9:16. Okay, let's come to this one. Three charges q, q and 4q are placed like this. So q is at 0, then this is at L by 2, capital Q is at L by 2, and 4q is over here, okay, which is at a distance L. Okay, so respectively from one end, in order to make the net force on q 0, so you want the net force F net on this small charge q to be 0. Okay, so basically this charge, basically this one, if you see, these two have the same charge, right? So this will repel each other. Okay, and this positive charge, this q charge should attract it, right? So this charge should be negative. So if you see, option D will be incorrect. First of all, you can neglect it, because this charge should have negative sign with respect to this, because this one is pushing it. Okay, these two are like charges, this is pushing it, so this one should attract, so that the net force is 0. Okay, so the one thing is for sure, that this charge should be negative, it should attract, okay, in order to cancel the force. Okay, now we just have to equate the force and find the magnitude of this charge. Okay, so force on small q due to this 4q, that is what I am writing. Okay, so it will be k q1 q2, so 4q into q by the distance square, which is L square. Okay, so force on q due to 4q, k q1 q2 by r square. Okay, now similarly force on q due to this capital Q, so capital q by L by 2 the whole square. So k will cancel, 1 q will cancel, L square can also get cancelled. So here we'll have 4q, and here we'll have q by this is 4q, right? This will be 4 in the denominator, go in the numerator. So basically your q will be equal to q but negative, right? This is magnitude, but here when we consider the direction of force, we know that this should be negative so that it attracts. So option A, minus q, is correct. Okay, yes, minus q is the correct choice over here. So that's about these two questions. Over to the next one. So let's come to question 10 and 11. Question 10 from projectile motion from 2D motion, and usually the questions from this section are based on projectile motion. No surprise, because 90% of the chapter is projectile motion. Okay, so here you are given the initial velocity of this projectile motion in vector form 3i cap plus 4j cap. You are supposed to tell what is the range of the projectile. Okay, so I know the formula for range is u square sine 2 theta by g. Okay, and sine 2 theta is 2 sine theta cos theta. Okay, I am writing it in that form because from this I can find my theta. Okay, I mean sine theta and cos theta, right? From this vector I can find my sine theta and cos theta. Okay, so I'll write it in the form 2u square sine theta cos theta by g. Okay, so that is how I can do this question, or you could have also done it by finding u cos theta from here. Okay, you can find u cos theta, and then you just have to take the time period, find the time of flight, 2u sin theta by g, and u cos theta times the time of flight will give you the horizontal range, right? Because the horizontal range, the basically it says distance into time, right? So distance is basically the distance is speed into time. Sorry. Okay, so the horizontal distance will be speed into time, which is u cos theta times the time of flight. Okay, because there is no acceleration in the x direction. You will reach to the same formula, but I'm thinking of doing it this way. Okay, so I can break this into two components, which is u cos theta and u sin theta. Okay, now this is our vector u, so I can find the magnitude of this vector. Okay, so if you see 3 and 4, right, 3 and 4 will give you 5, right, under root 3 square, basically Pythagoras. Okay, so 3 and 4 gives you 5, so this u is nothing but 5. Okay, this is 5 cos theta and this will be 5 sin theta. Okay, so you can see that sin theta will be nothing but, so basically this is forming a triangle like this, right? So it is 3i cap, so 3 in the x direction, 4 in the y direction, and the hypotenuse, which is the resultant, will be 5. Okay, so sin theta from here is nothing but, sin theta will be, we don't want this u cos theta and u sin theta, we basically want sin theta and cos theta, right? So sin theta will be 4 by 5, right, opposite upon hypotenuse. Cos theta will be 3 by 5, right? So you can substitute it over here. Okay, so 2 u square will be the resultant square, which is 5 into 5l, right, because it will cancel out with sin theta and cos theta. So sin theta 4 by 5, cos theta 3 by 5, and g is 10. Okay, 5 cancels with 5, 5 cancels with 5, and we have what do we have? Okay, so I can cancel this also, or I won't, because if you see, this is 2 4s are 8, 8 into 3 is 24, 24 by 10 is 2.4. So 2.4 meters, which is option B, is correct. Okay, let's come to this one. Here we are given a solenoid, n is given, number of turns is 1200, okay, and the length of this is given as 2 meters. Okay, you are supposed to find the magnetic intensity at the center of the solenoid. Now you might feel that magnetic intensity is nothing but this mu 0 ni. You might know this formula, and hopefully you might also know that the small n is capital N by n, L, right, number of turns per unit length. Okay, but that is not the case. Here you are asked for magnetic intensity, okay, not magnetic field. Sometimes these terms are used interchangeably, sometimes they are not. Okay, because magnetic intensity is H, remember from today. Okay, so sometimes they might use it interchangeably. Okay, sometimes they might say magnetic intensity and ask you to find magnetic field, but here it is not the case. Okay, or the best way to look at this type of question is to look at the units. Okay, so if you see the units in the answers over here is ampere per meter, which is the unit for intensity, H. Okay, not for magnetic field. This has units of Tesla, Weber per meter square, or Tesla. Okay, so remember the units, see for the units in the answer, and then only decide what quantity it is. Does magnetic intensity mean? Does it mean magnetic field? Simply are the options in Tesla, or are the options in ampere per meter? Okay, so if it's in ampere per meter, it means H, and H is nothing but B by mu 0. Okay, so B by mu 0, so basically it is Ni. right? Now N, I've told you it is number of turns per unit length. Fine. And what is the current? Current is 2 amperes. Very fine. So this is 1200 or 1.2 into 10 to the power 3. Just a fancy way of writing. So 1, 2, 3, shift the decimals to the left side and raise to that power. Okay. So option B is correct. Over to the next question. Question 12 and 13 over here. In question 12, we have a temperature scale X. The boiling point of water on this scale X is 65 degrees X and the freezing point is minus 15 degrees X. You are supposed to tell what will be the value of minus 95 degree X on the Fahrenheit scale. Okay, now the important concept that we are going to use over here is that for any temperature scale, the value of its temperature, a particular temperature T minus the freezing point, okay, minus I can say the low point LP, I'll say lower point, freezing point, and the difference of the boiling point minus freezing point will be constant. Okay, so we'll use this for scale X. So this is constant. Use this for scale X and equate it to scale Y. Okay, scale X and the Fahrenheit scale. Okay, so for this you'll need to know the freezing point and the boiling point of water on the Fahrenheit scale, or you can use the relation. For Fahrenheit scale it is 9 by 5 degrees Celsius plus 32, right? So if you know it in degrees Celsius, which I assume you know, so 0 and 100, right? So that will give you the value in the Fahrenheit scale. Okay, so T, so let us write this for X scale over here and this is for Fahrenheit scale. Okay, so these two will be equal, okay, because this ratio is constant. So T, what is the temperature on the X scale that we want to correspond to the Fahrenheit temperature? So it is minus 95. Okay, this temperature we want to find it in Fahrenheit. So, okay, this is the random temperature minus the lower point which is the freezing point is minus 15, place it with sign, so plus 15 it will become, right? Let's come to this one. Boiling point of water is 65, okay, and the freezing point is minus 15, place it with sign plus 15. Okay, let's come over here. Temperature on the Fahrenheit scale, this is what we are supposed to find. F, let us call it. Okay, this F we are supposed to find. What does this 95 correspond to? What F it corresponds to, minus what is the freezing point on the Fahrenheit scale. So C is equal to 0, which means 32, right? 32 is the freezing point, and here the boiling point is 212. This will become 100, and yes, that will give 180 plus 32, 212 minus 32, right? So you have to check on these values. What are these values now? So this will give us 80, right? Minus 80. So this is minus 80. 65 plus 15, that is also 80. Yeah. And this is F minus 32. And this is, what is this? So 212 minus 32, it was over here, right? So 180, I believe. So this and this will cancel, this will be minus 1. So minus 180, bring this over here, and F minus 32. So F is nothing but 180 minus 180 plus 32. So I can add 40, so minus 140 plus subtract 8, okay, minus 148, which is option D. Okay, you can calculate this will be minus 148. Okay, so the concept is simple. For any temperature, linear temperature scale, this ratio is constant, so you just have to equate it to that. Okay, so one key remark I will say, please remember at least the relation or the freezing and the boiling point of water in different scales. Okay, for Fahrenheit you can remember, for Kelvin you can remember, and Celsius you'll obviously know. You can remember the conversion or this directly, 32 and 212. Okay, or at least remember the conversion. And also for Kelvin it's just plus or minus 273, right, if you know the in Celsius. Okay, so here in series combination of LC circuit, so we have LCR circuit. Okay, then it is at resonance. Okay, so omega is equal to 1 by LC, you can say. Okay, or you're supposed to find impedance in this case. So impedance basically for any AC circuit is, so if you have XL LRC, then the impedance is like this, right? XL minus XC, okay, the whole square, they are impedance, the reactive ones, reactive and the inductive ones, sorry, inductive and the capacitive ones and the resistance. Okay, now at resonance you know that XL is equal to XC, right? That is how you obtain this relation in first place, right? This comes from here. Okay, so here XL is equal to XC, which means Z is equal to under root of R square, or basically it is R. Okay, so or you might directly know that at resonance the capacitive and the inductive terms do not have any impedances, they cancel out each other, and only the resistive part survives. Okay, so it behaves as a purely resistive circuit. The resistance is given as 20 ohms, so it will remain 20 ohms, it will not become 0, a point to keep in mind. Okay, the reactance will basically equal resistance at resonance. Okay, so let's move to the next question. 14 and 15, with the completion of these two questions we will be halfway done, so stick around and let's get this done. Okay, so question 14, here we have been given the potential, gravitational potential due to a uniformly charged sphere, not charge, it's gravitational potential. So a sphere of uniform density on its surface is V. Okay, you are supposed to tell what will be the potential at the center. Okay, then its volume at the center of the sphere. Okay, something is missing in this question. Okay, then the value, its value, then the value at the center of its, okay, value of the potential at the center. Okay, V is at the surface, what is the value of the potential at the center? Now this sphere has uniform mass, right? So basically the formula for this, I'm not expecting you to remember this, but this is something a bit complicated. There is a method to derive this. Okay, because the charge is spread, or you can think it in terms of electrostatics, the potential inside will not be 0, right? Electric field inside a conductor is 0, but you can think of a dielectric sphere. Okay, the charge will be spread uniformly inside the sphere, inside the solid sphere. Okay, it's a dielectric. Okay, so the charges do not come to the surface only, it resides inside, right? Dielectric. Okay, so same, the mass is spread uniformly inside. Okay, so for that case the electric potential is k cube by r cube, and same relation over here, and here it is gm by r cube. Okay, so you can relate and remember, or you can directly remember the result that we are going to obtain over here. Okay, here r is the distance from the center at which you want to find the field, and capital R is the radius. So small r will be basically 0 over here, because we are supposed to find at the center. So gm by r cube, so this term will be 0 and will have 1.5 times r cube. Okay, so this r square, right? So this r square will cancel with this, so you'll have 1.5 gm by r. Now gm by r is nothing but is the potential at the surface. You can equate this to r. Okay, so this will become r square, and so if I equate it to r is equal to r, you can see that v is equal to gm by r cube. So this will be 1.5 r square minus 0.5 capital R square, same r square, right? So it will be 1 r square. Okay, so you can see from here that the V value, the potential at the surface, which we are given as V, is nothing but, this is at the center, I will say, this is nothing but gm by r. So this is nothing but 1 point times potential at surface, which is basically V. We are given as V. Okay, so the potential on the center, at the center, is 3V by 2. You might also remember the graph that comes along with this, like this, somewhat like this, right? Like this. So here it is 1 point times 5 Vs, and here on the surface it is Vs, and then it falls as 1 by R. Okay, the potential. Let's come to this one. Here we are supposed to find the ratios at 2 points P and Q. On the screen in Young's double slit experiment, you are given that the phase difference is this. Okay, basically amplitude for your Young's double slit experiment is like this, right? If the intensity at each source is I0, so the resultant will be 4 I0, and here it will be basically it depends upon cos square phi by 2. Yeah, I'll just write it as I0. You need not worry about that. You can see that it depends upon cos square, right? So I1 by, or IP by IQ, you can find it easily. This phi is phase difference, which we are given in the question. Okay, so cos square phi by 2, first is pi by 3, which is 60 degrees. 60 by half is 30, or I will write it as pi by 6, cos 60, cos 30. Okay, and here it is cos square pi by 2. Pi by 2 by 2 is pi by 4. Okay, so pi by 4 is 1 by root 2, right? So 1 by root 2 square, so that is half. And here we will get sine 30 is half, cos 30 will be root 3 by 2. So root 3 by 2 square that 3 by 4, right? So we will say 3 by 4 times 2, which is 3 by 2. Is it 3 by 2? Option C. Let me check that. Yes, it is 3 by 2. Option C. Okay. So those were the two questions. I think this was a bit tricky, but I hope you remember this relation now on, or directly remember that the potential at the surface is 1 point times the potential at the center is 1.5 times the potential at the surface. Okay, so that's about these two questions. We are halfway done. Let's move to the later section of this video. Question 16 and 17 over here. In question 16, we have a particle of mass m which is under projectile motion. Okay, so and this is at a velocity v at a direction theta. Okay, at the highest point, it will split into two masses of equal mass. Okay, we'll consider this as 2m. Okay, and this will be m and m, or if you're getting confused because it's mentioned in the question, so we'll take it as m by 2 and m by 2. Okay, you can also do it the other way, which I was trying, but anyways. Okay, so m splits into m by 2 and m by 2 at the highest point of its projectile motion. This m by 2 continues with the same velocity and completes the trajectory. Okay, it continues to move along the same path. What will happen to m2? Okay, what is the velocity of m2? Okay, or m by 2, the other piece. Okay, one piece continues along the same motion. What will happen to the other piece? Okay, so we just have to equate the momentum, initial and final, because explosion is due to internal forces. Okay, momentum is conserved. Okay, so initial momentum m into at the highest point. Okay, this is at the highest point we are equating the two momentums. So at the initial case, it will be m into v cos theta, right? Because at the highest point, only the cos component of the motion survives, right? For a projectile motion, only the cos component is available at the highest point, right? Because there is no sine component, so no vertical motion. So that is the highest point. Okay, so and here we'll have m by 2, and what happens to this first piece we don't know. We have to find its velocity, and the second piece m by 2 continues with the same motion, so which means it has the same velocity v cos theta. Okay, now you can cancel m throughout. Okay, I can take this 2, so 2 v cos theta, okay, minus v cos theta will give you the value of this v. Okay, so which will be v cos theta. Okay, so option B, v cos theta, is the correct choice over here. Okay, actually this first piece and second piece is a bit confusing. I got reminded of one Akbar Birbal story by that. I'll tell you by the end of this question. Okay, so let's solve this one first. So here we are given that de Broglie length of electron and proton are equal. You are supposed to find the ratio of their momentum. The masses are given, but just to confuse you, because de Broglie length is nothing but h by p, right? De Broglie wavelength is this. Okay, so here you can see h and h are constant, so momentum, both the momentums are equal, which means their ratio is 1:1. You don't have to use mass and velocity or nothing. You know that de Broglie wavelengths are equal, then momentums will be equal, because this is directly or inversely proportional to momentum. Okay, so that was a clear-cut concept. The story that I wanted to tell you was once Akbar asked Birbal to get two apples for him. Okay, so he goes to the shop and buys 2 apples, and while returning he brings only one. Okay, so Akbar is like, where is the second one? So Birbal hands him the apple and he's like, here, this is the second one. So he's like, where is the second one? I asked you to get 2 apples, where is the second one? Okay, so he's like, yeah, that is the second one. So he just loses his mind. Where is the second one? I asked you to get 2 apples, you are just giving me this one and you are telling me that you bought 2, where is the second one? Okay, then finally it hits him that he should ask, where is the first one? Okay, because the one that he is handing him is the second one. Okay, so that's a bit messed up over here. Finally he asks, where is the first one, and then he hands him the first one. Okay, so that was the story. Very embarrassing, cringe. Anyways, that reminded me from this. Okay, because here there are 2 parts, and which one is doing what, I don't know. Yeah, That's my cringe story. Over to the next question. Question 18 and 19. In question 18, we have 1000 droplets. Surface tension is given, having same radii 1 millimeter each, combined to form a single drop. Okay, you are supposed to tell what is the surface energy of this process. Okay, when they change from 1000 drops to one big drop. Okay, so first of all, we can find the radius of the one big drop by equating the volumes of the small drop equal to the volume of the bigger drop. Big, okay, small, n times, right? The 1000 times the volume of the small ones, 4 upon 3 pi r cube, okay, is equal to 4 upon 3 pi capital R cube. Okay, the volume will remain constant, so this will get cancelled, and R cube is 1 millimeter, so this is 1000 and 1 millimeter, so I can say, or this is okay, better way of writing 10 to the power 3, and this is millimeter cube, right, and this is r cube. So r cube basically is, r is 10 millimeters. Okay, I am writing in millimeter only, later I will convert. So you are supposed to tell the surface energy. Okay, surface energy is basically surface tension into area, right? So the surface energy S is equal to T into area, or the change in area of it, right, delta. Okay, so there is some change in area, of course, because the small drops are coming together and forming a big drop. Okay, so we can find the change in area. The area of the bigger drop will be less, okay, so that it is stable. Okay, so anyways, let's find that the change in area multiplied by surface tension, and that will give us surface energy. Okay, so this S will be equal to T is surface tension is 0.07. Now area of the small drops, okay, there are 1000 drops, keep that in mind. So pi r square into 1000. Okay, you have to keep that in mind. Okay, if you don't use that 1000, you might end up at some different answer. Okay, so there are 1000 drops, so 1000 times the area of one drop. Okay, then we have one big drop, so that is basically pi capital R square. Okay, now let us substitute 0.07, pi comes out, pi we can write it as 22 by 7. Thank you question, I would have never known. Here it is 1000 minus R is 10, right? I'm placing in millimeters only, capital R is 10, so 10 square is 100, and the millimeter factor, now we'll have millimeter square, right? Here r square, so we get millimeter square common. So millimeter square, 1 millimeter is 10 to the power minus 3, and that squared is 10 to the power minus 6. Okay, so I have converted it in meters, okay, because we want answers in joules, standard unit. Okay, so this is 0.01, so this is 10 to the power minus 2, 22 into okay, what is this, 100 minus 1000 minus 100, that is 900 into 10 to the power minus 6. Okay, so I can say this 10 to the power 2 and this can get cancelled. This is 22 into 9, 99 into 2, 99 into 2. Okay, something missing over here, pi r square, let me check. Okay, so a big thing missing, because this is a sphere, right, and the surface area will be 4 pi r square. One 4 factor is missing over there, so that was causing confusion. So 88 into 9, which is here it will be 10 to the power minus 6 only. Here it will be 792. Okay, you can check it. 8 9s are 72, 8 9s are, so 720 plus 72, 792. And 10 to the power minus 6, or you can write it as 7.92 into 10 to the power minus 4, which is option B. Okay, so don't forget this 1000, don't forget this 4. Okay, it's a sphere, 4 pi r square, the area is 4 pi r square. Okay, my bad. Let's come to this one, the effect of temperature on temperature increase on the number of electrons in the conduction, and also the effect of temperature increase on resistor respectively. Okay, so basically when you increase the temperature, so there is band gap, right? The electrons are there in the valence band, you make them go to the conduction band, and when you increase the temperature, these electrons will get energy and they can move easily to the conduction band. So n, the number of electrons in the conduction band will increase, right? So Ne will increase. The only option that is showing this is option C. You can also verify that resistance will decrease because number of electrons increase in the conduction band, more conduction, less resistance, right? Or you can see the lane wise, lane B, the formula, okay? Resistivity is m by Ne square tau, right? M by Ne square tau. Okay, so the N is in the denominator, so which means resistivity is inversely proportional to the number of charge carriers, right? Increase in the charge carriers, resistivity will decrease and the resistance will decrease. Okay, so that's about this question. Let's move to question 20 now. Question 20 and 21 over here. Here in this question, we are told that at what position will the kinetic energy and potential energy for SHM be equal? Okay, some of you might know it as a standard question, and the answer will be amplitude by root, right? The way to do is you just have to equate kinetic and potential energy, right? Potential energy for SHM half kx square, right? Potential energy, sorry, kinetic energy will be there is no direct way, you just have to take total energy, which is half k a square minus the potential energy, right? Total energy is constant for SHM, half k a square, and minus the kinetic energy. Okay, so you can see half get cancelled, half k, so a square minus x square is x square, so a square is 2x square, which means a is a by root 2 is x, right? You take root 2 to the other side and take root. Okay, so a by root 2 is a point where kinetic and potential energies are equal. Okay, let's come to this one. Here we are bombarding atom at room temperature with this energy electron. Okay, you are supposed to tell the number of spectral lengths. Okay, now this energy will be utilized to excite the atom, right? We know the atomic energy levels. En is minus 13.6 electron volts by n square, right? So E1, n is 1, so that will be minus 13.6. For E2, what is the value? Around 3.4, right? 3.4 electron volts, right? When you put n is equal to 2, so divide by 4 basically. E3 will be around 1.51, E4 will be 0.85, okay? So we are supposed to see, adding this 12.5 to 13.6, what is the excited state that we obtain? Okay, I can add minus 13.6, I know I can add, of course, that is even a 6-year-old can do that. Anyways, so here if I add this, okay, what I'll do, subtract this and I'll change the sign later. So this is 1 and this is 1.1, right? So around this energy, or this hard to convince. Okay, so I'll do this. Okay, I'll take the difference between these two energies. Okay, I'll see that if this energy is less than this, because this is the maximum energy that our electron can provide to the atom, right? So let us see the difference between E3 and E1. Okay, so 13.6 minus 1.51. Okay, 60 minus 59 is 0.9, believe, and this is this 12.9. Okay, of course with the negative sign, but you can see that this difference is less than this. Okay, which means our electron can provide this much energy. Okay, higher than this, of course. Okay, so it can excite our atom to the third energy level. Okay, if you try it with fourth one, it won't happen. Okay, it is around 0.85. So if you see the difference, this will be greater than 12.5. Okay, so our electron which is being bombarded on that atom cannot excite it to E4. The maximum it can excite it is to E3. Okay, so you have to just find the number of spectral lines from E3 to E1. That is the question now. So the question basically boils down to this. Okay, and it's very simple. You can see you can have E3 to E2, right? E3 to directly to E1. Okay, and E3 to E2 and E2 to E1. So 3 spectral lines, or you can use the formula n into n minus 1 by 2. If the final state is 1, this formula gives you number of spectral lines, okay, provided the final state is 1. Okay, so n is the value of the highest state. So 3 into 3 minus 1, which is 2 by 2, so this is 3. Okay, so option C. So you just have to see to which energy level this much amount of energy are basically our electron can excite the atom to. Okay, so that is our question. Over to the next one. Don't know about you, but I'm feeling 22. So question 22 over here, a thermodynamic system is taken through a cyclic process is shown. You are supposed to tell what is the work done in the process. You can see it is a PV graph. Work done is nothing but P into delta V, right? Or the change in PV, basically the product, right? So basically if you have distance, you can, if you have speed time graph, you can find it, find the distance via finding the area under the speed time graph. Here also the work done is nothing but the product of P and V, right? So here also the work done will be area under this graph, okay? Area under this graph meaning area in this curve, okay? That the process is, okay? So you can basically find the work by finding the area, okay? Half base is what? 4 minus 2, which is 2, and height is 400 minus 100, which is 300. So this is 300 joules, okay? And do let me know in the comment section, why is this sign positive, okay? Why is it not negative, okay? So this could have been plus 300 or minus 300. What decides the sign over here, okay? Answer is plus 300, of course, but why is it positive, okay? Do let me know answers in the comment section. The correct answer receives a heart from me, okay? So anyways, it's not there in the option, so no confusion over there. But even if there was a minus 300, you would have selected plus 300, okay? Why is that? Let me know, okay? So let's come to question 23, Young's modulus and Young's double slit experiment, and here we have been given the part difference at 2 points, okay, in form of wavelength, and I1 and I2 are the intensities at those points. I0 denote the intensity produced by individual slit. You are supposed to find this ratio, okay? Now what is the equation for intensity? It is I0 cos square phi by 2, right? Now this phi is phase difference, okay? From part difference, which is given in this question, we can find the phase difference, okay? And also I0 is the intensity of individual slit. So here we have to use 4 I0 basically, because we have to compute this ratio, okay? So I'll convince you on that. Imax will be, okay, here the value is Imax, right? So Imax is given as under root of I1 plus under root of I2 the whole square, right? Each one is I0, 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 under root, I0, I0, so 2 times of I0, okay? So this will give us 2 times of under root I0 and that square. So that will give us 4 I0, right? So 4 I0 is the maximum intensity at certain point, okay, at the central bright spot, you can say, okay? So that is the maximum intensity. At the other points it will depend upon the phase difference, okay? So at first point we can find the phase difference. Phase difference will be 2 pi by lambda into this phase difference that is given, because I'll convince you on that also, because if you see 2 pi corresponds to lambda, right? Complete wavelength corresponds to 2 pi degree shift, right? This is like a complete circle, okay? So that corresponds to lambda. So your lambda by 3 will correspond to what? Okay, that is what we are finding, okay? That is phi 1, okay? So 2 pi by lambda times lambda by 3 will give you this, okay? So that will be 2 pi by 3, okay? That is lambda 1. Similarly lambda 2, sorry, phi 2, the phase 2 is 2 pi by lambda times this angle, which is, okay, first one was lambda by 4, so we'll say it is pi by 2, okay, fine. And second one was lambda by 3, which is, now it will give 2 pi by 3, okay? Now we can find I1. I1 will be 4 I0 cos square pi by 2, and this 2, so cos square pi by 4, cos square pi by 4, which is 1 by root 2, 1 by root 2, that square is 2, right? So this and this cancels, you get 2 I0, okay? So I1 is 2 I0, and I2 you can find similarly, so 4 I0 into cos square, is this 2 pi by 3, and that you divide by 2, so pi by 3, so cos square pi by 3, sorry, pi by 3, which is what? Cos 30 or cos 60, cos 60 half, so that squared is 1 by 4, so this 4 and 4 gets cancelled, you get I0. So I1 and I2 values you have obtained, you can easily obtain this ratio now, okay? So I1 plus I2, so I1 plus I2, so 3 I naught by I naught, which is 3. Okay, let me confirm that. Is it 3? Is it 3? Yeah, it is 3. Okay, I've not marked it on the answer as well, but I think it is 3. Okay, so that is your answer. Over to the next question. 24 and 25. Okay, so here in question 24 we have a bicycle tire with air pressure that at temperature this, the approximate pressure of the air in the tire when the temperature increases to 36 degrees Celsius. Okay, so now it is not mentioned in the question, but you are supposed to take the volume as constant, otherwise this is not easy to solve. So PV is equal to nRT we can use, and you can see that if volume is constant, P is directly proportional to T, right? So P1 by P2 is T2 by T1 by T2, direct relation. Okay, so here you are supposed to find the pressure, right? Pressure increases to, so P1 is equal to T2 by P1 into T2 by T1 is P2, right? So P1 is 270, okay, and T2 is, what is T2? Temperature in the second case 36, 36 plus 273 or 27 plus 273 is 300, which is T1, and T2 will be 36 is how much more? 3 and 6, 9. So 309. Okay, let me check the answer as well because it's a bit difficult to calculate. It's 309 and this is 100. Okay, it's not that difficult to calculate. 103, this is P2, and this can get cancelled. Okay, and 27 into 103 is around, I think this will be the answer. Okay, so you can calculate it. 27 into 103. Okay, 7 3s are 21. Yeah, around that will be the answer, right? Because yes. So let's come to this one. A thin prism P1 angle 6 degrees, refractive index is given. P2 angle refractive index is given, and you are supposed to tell the angle of prism P2 for deviation without dispersion. Now deviation in case of small prism is A into mu minus 1, right? So for now these are combined and there is dispersion without deviation, without average deviation. Okay, so the deviation produced by one is nullified by the second one. So both of the deviations are equal but opposite, they are combined in the opposite sense, right? So they are cancelling out each other, so there is dispersion but no deviation as such. Okay, so you can equate this two and find, right? So a1 is what? The angle of the prism 1, 6 degrees into mu minus 1, which is 1.54 minus 1, and this is what is this? A2 we are supposed to find 1.72 minus 1, so this is 6 into 0.54 divided by 0.72, right? I think that's can be cancelled, I believe. 6 9s are and 6 1s are 6 2s are, right? So 6 9s are 54, 0.09, and 6 0 1s are and 6 2s are. Why I'm so slow? Into 9 by 12, so this is 2 and 9 by 2 is the angle. Okay, A2 is nothing but 4.5 degrees. So option B is correct. Option D is correct. Okay, so that's about these two questions. Let's move to the final 5 questions for this. 26 and 27. In 26 we have a question from Young's modulus. Okay, as expected from elasticity, you are supposed to find, what are you supposed to find? You are given the length, area of cross section is given, Young's modulus is given, load is given, you are supposed to find the elongation. So simply use FL by A delta, right? Young's modulus is stress is force by area, and strain is change in dimension to original dimension, stress by strain, right? So you are supposed to find delta L, so FL by A1, right? So F is what? Force is the load, 250 newtons. Then we have length is 100 meters. Then we have area, 6.25 into 10 to the power minus 4. 6.25 into 10 to the power minus 4. Okay, and then we have the Young's modulus, which is 10 to the power 10. Okay, So I think we can cancel this somehow. So if I write 25 into this will be 10 to the power 4, and here we'll have 10 to the power 6, right? Okay, this is not 10 to the power 4, this is 10 to the power 3, 2 and 1 3, and I can also write this as 625 into 10 to the power minus 2, right? So this is 1 by 25, this is 25 square, right? So what is next? So 1 by 25 into, this is 10 to the power 4 and this is 10 to the power minus 1. So what I can do is I can multiply 4 and divide by 4, okay, because this will become 100. So 4 into 10 to the power minus 1 upon 100. So this is basically 4 into 10 to the power minus 3, right? 1 and this 2, 3, which is option D. Okay, let's come to this one. Here we have a radioactive source. Okay, let me check that. This is also an option, right? So yeah, it's D only. Question 27, a radioactive source goes to 1/8, okay, 1/8 of its initial concentration in 3 days. That didn't help. Okay, if this much amount of material is left after 5 days, okay, you are supposed to tell the initial amount of material. Now initially suppose there is n naught after one half-life, so I am counting after each half-life. So after one half-life, 1 t half and 2 t half, will have n0 by 4 and so on, right? So if you see the thing over here, after 3 days, what is happening? After 3 days it is becoming 1/8. Okay, when does the concentration becomes 1/8? 1/8 it becomes after 3 half-lives. Okay, so 3 half-lives is basically 3 days, right? Because after 3 half-lives, the concentration, you can also use the radioactive law. I'm doing it smartly over here. So after sequential half-lives, I've written the concentration. They have told that it becomes 1/8. I know it is a multiple of 2, that's why I'm using this logic. So 1/8 it will become after 3 half-lives. 3 half-lives, and here they have given it as 3 days. So 3 half-lives will equal 3 days, or one half-life will be 1 day, right? And they have told us in 5 days the concentration is this. So n0 by 2 to the power 5 is this, okay, because this is after 5 half-lives. Okay, but after 5 half-lives this will become, so if you see the pattern, after 1 half-life it is 2 raised to 1, this is 2 raised to 2, third half-life 2 raised to 3. So after 5 days, which are 5 half-lives, we know it from here, so it will be 8 into 10 to the power minus 3. Okay, so n0 is 2 to the power 5 is 32, 32 into 8 into 10 to the power minus 3, right? 32 into 8, 3 8s are 24 and 16, or 240 plus 16, 256, right? So that is into 10 to the power minus 3, or this is grams, right? This is in kg, so 10 to the power minus 3 kg is 256 grams, which is option D again. Okay, so yeah, that is your question number 27. Let's move to 28 and 29, which will be the last question that I'll be doing today. 30 is your homework question, of course. Coming to question 28, here we have a plate. Okay, plate has a length of 20 centimeters, and we have cut out symmetric circles of 5 centimeters like this. Okay, as shown in the figure, you are supposed to tell what is the moment of inertia of the remaining part. Now the spheres are not the spheres, the circles are cut out from this plate. Then what is the moment of inertia of the remaining plate about the z-axis. So this is, the plane is x and y axis. So the z-axis is like this. Okay, z-axis is like this, plane is rotating like this in the xy plane. Okay, so let us find this out. So first of all, we can find the moment of inertia of plate. Moment of inertia of plate. Okay, for a plate passing through its center, moment of inertia is given as ml square by 6. I hope you know it. Okay, for a square plate, moment of inertia about this axis will be ml square by 6. Now length is 4r. Okay, so m 4r, so I can write 16r square by 6, or I can write 8 by 3. Right, 16 cancel it with 2, so 8m 8 mr square. Now I'm going to use capital M for plate and small m for a circle, one circle. Okay, don't confuse. I write it very similar. Okay, so now let us do the discussion for circle. Okay, one circle. We'll multiply the results with 4 later. So let us discuss for this circle over here. Okay, so what is the mass of this circle? First of all, we can find the surface density. Okay, because this is uniform. Then we'll have the total mass, capital mass of the plate. Okay, of the plate divided by 4r squared. This is the density, right? Surface density, surface mass density. So m by 4r square. Okay, sorry, 4r the whole square, length square. Okay, so this is 16r square. This is the surface density. Now for one circle, I want to find this mass m. Okay, one circle mass m will be given as sigma times of area, right? Because for the entire plate, the mass is this. Okay, this is uniformly distributed. Okay, so m by 16 pi r square, that uniform mass times the area, mass times the area will give you the mass of the element that you are asking. Okay, so here what is the area, sorry, what is the mass? This is capital M, this is small m. Okay, so here we have 16 r square into pi r square. R square cancels with r square. We have the mass of a single circle as 16 capital M by pi capital M by 16. Small m is pi capital M by 16. This is for one circle. You can multiply it by 4, that will get the mass of 4 circle elements. Okay, but for now let's keep the discussion with one circle only. We'll do it while calculating the moment of inertia. So what is the moment of inertia? Now we have the mass, right? Mass of the circle. We have to find moment of inertia, which will be mr square, right? But it is about, we want to find about this axis, not about the center. Okay, so we have to use parallel axis theorem. So the moment of inertia about this z axis, which is coming out, about z axis, this is for circle only, for one circle. Okay, iz, moment of inertia about the z axis, will be moment of inertia about the center of mass plus moment of inertia plus moment of inertia, plus the total mass, which is the m for the circle. Okay, small m into d square. Okay, I want to check something. Okay, so moment of inertia for the circle, it is like a disk, right? It is like a disk, so it will be mr square by 2. So m, radius is r only, so mr square by 2 plus mass of the circle, this pi capital M by 16 into d square, the distance between here and here. Okay, the distance between the two parallel axes, right? One is passing through the center of mass, one is at this d distance. Okay, so the distance between them is x, right? We can find it easily. This will also be r, and this is r, so this will be r. So r, and you have to find the hypotenuse. So x will be r root 2, right? R and r in a triangle, right angle, will give you hypotenuse as r root 2. Okay, so this d is nothing but, I can call it d. D is r root 2. So r root 2 square, so 2r square. Okay, so what does this give us? So 2 can cancel with this, and we'll have mr square by, actually you can take this common, 1 plus pi by 4, right? So give us this, and okay, I hope this is correct. Now the next thing that we are supposed to do, we can multiply this time with 4, because we have 4 circles, and basically the moment of inertia, I net, that we are supposed to find will be this initial I that we calculated minus that for the circle. So I minus I for the circle, I dash, which we call 4 times. Okay, because there are 4 circles. Okay, so I is r, what is I? I is m by 16 r square minus 4 times of this. 4 times of this, I can actually write 2 mr square, into 1 plus pi by 4. Okay, you can solve this and the answer will come out to be around, okay, this is not like this is 8 by 3, right? 8 by 3 mr square minus this 4 times this. Okay, so if you solve this, you plug in the values. R is 5 centimeters, mass is 1 kg, so you can just remove that m and plug in the value of pi, and you should get to an answer of 0.00017. 0.0017. Okay, actually you could guess it too, because the radiuses are given in centimeters, if you see, and moment of inertia is proportional to r square, so centimeter square will be 10 to the power minus 4, right? So in meters, right? So kg meter square, some 10 to the power minus 4 sort of answer you should get. Small correction, while substituting m over here, I made a mistake. Okay, so here if you see, this m is mass of circle. I told you, right? It is small m. You can see it's the I of center of mass of the element, which is the circle over here. So circle, mass of circle, it's small m only. So here ICM is also small m. Okay, so m, this is r root 2, right? R root 2 square, so mr square, 2mr square it will give you, and this mass is also small m. Okay, I about center of mass of the circle, right? So this is not capital M, so it is small m only. So 2 plus this is 5 mr square by 2. Now you can put the value of capital M as pi m by, sorry, capital M. So this is small m. I'm messing up, sorry. So pi m by 16 into r square. Now this will get modified as 5 pi m r square by 60. Okay, now if you solve this and times 4, right? Now if you solve this, you will get the answer as this. Okay, my bad, mistake, apologies. Okay, so that is the way you do it. There was small m over here, I mistook it for capital M. So you have to be very careful, or you use some other notation for the masses. Okay, so that is one thing to be careful about. That's about this question. Over to the last two questions now. So here is question 29 and 30. In question 29, we have a simple pendulum which is taken aside to a certain height. Okay, we can say at an angle theta from its equilibrium position. Okay, this length of the string is L, as we know, and you are supposed to tell when it is released from here what will be the velocity at the equilibrium position over here. Okay, it will be somewhat like this, right? So it's very simple. You are just supposed to see what this height is, and then you can use conservation of energy. This height will be basically, this is L, right? This is also L. This is length. Okay, this is L. So what will be the projection of this? What will be this length over here? That will be nothing but L cos theta, right? Because it is parallel to theta. Adjacent to theta. Okay, L cos theta. Okay, so that will be L cos theta. So the height is nothing but L minus L cos theta, or I can write it as L into 1 minus cos theta. Okay, L minus L cos theta will give you this height, right? So you can use now mgh is equal to half mv square. Okay, the potential energy at this point will be equal to the kinetic energy at this point. This point it will be purely kinetic. If the reference potential is 0, m and m will get cancelled. 2gh, right? Under root 2gh. This is the velocity that you obtain. Okay, you could have directly used the relation. So 2gh is L 1 minus cos theta, which is option D. Okay, question 30 is your homework question. You will try it and let me know the answers in the comment section of this video. I hope you enjoyed this session, and we'll continue with the series for a while now, up till 10 episodes. So you'll have, by the end of the series, as I said, 300 questions. Okay, 300 most probable BITSAT 2024 question. Okay, make the most use of it. Okay, do consider subscribing if you're new to this channel, and if you want to follow this grind throughout. I'll be also starting with the strategy series, which helped a lot of the 2022 aspirants they had given me a good feedback on that series. So I'll be starting with that series soon, and I'll be guiding you for your journey on BITSAT 2024. Okay, so if you wish to join that, do consider subscribing, and do check out the other videos which are the mock test videos, or the ACE series, which are the previous year questions of BITSAT that we did previously on this channel. All of those you can go to the playlist link and just watch. Okay, this channel is a gold mine for all the BITSAT aspirants out there. So my best wishes to each one of you. What am I saying? Okay, and that's the end of today's video. I hope you really enjoyed it. I'll see you soon in the next one. Till then, keep enjoying physics.